If you wanna level up your JavaScript skills or build your own game, this course is for you. In this video, we'll create a classic Minesweeper game with retro visuals and sound effects. Using React, the most popular JavaScript library for building user interfaces, we'll bring this game to life step by step. But before we dive in, let's take a look at the finished game that we'll be building. At the center of the screen, we have our game surface. At the top, we have a header displaying all the useful information about our game, such as mines count to reveal, buttons to start a new game or restart the current one, and timer that tracks how long you've been playing. In the center, we have our main board with cells where we actually can play with our mouse. And at the bottom of the game block, we have 3 buttons to set the difficulty level. This button adjusts the size of the board, making it from small to the bigger ones, and also adjusting the number of mines on the board. And if you don't know the rules of the Minesweeper game, here's what you need to know. If you uncover an empty cell, it reveals all the adjacent cells automatically until all connected empty cells are revealed. But if you uncover a cell with a number, it shows how many mines around this cell in all 8 directions. And if you uncover a mine, let's find a mine, maybe here, I'm sure it's here, the game is over. You win by uncovering all non-mine cells, or also you win by flagging all mines correctly. Let me show you how it works. And the last mine is here. I placed a flag on the last mine cell and it says you win. So we win by flagging all the cells correctly, and even without opening the last untouched cell. And before we start building the game, let's discuss the algorithm first. The level system of the game includes 3 levels ranging from easy to expert. They differ by the game board size and the total mines on the board. So on the easy level you have 9x9 board with total 10 mines on the board. On the medium level you have 16x16 board with 40 mines on the board. And on the expert mode you have 30x16 board with 99 total mines. So how do we initialize the game? We start by creating a 2-dimensional grid to hold data for each cell. In JavaScript, this will be implemented as an array of arrays, in which each cell will be an object that tracks if it's mined, flagged, opened or closed, or contains a number that indicates how many mines are around this cell. Then we randomly select positions for mines across the board and set a value property to mine. Next, for each cell without a mine, we count the number of adjacent cells containing mines. This includes cells in all 8 possible directions. And we set value to a number of adjacent mines. When you make a first move, we start a timer. And when you place a flag, we also show how many mines left to find. Each cell has its own structure to keep track of its state. The first property is value. It could be a mine indicating that the cell contains mine. It could be a number showing adjacent mines, or empty, which is null. The second property is flagged. It is a boolean value that tracks if a cell is flagged by the player. And also flagged cells can't be opened with a left click. The third property is opened. It is also boolean and it marks if the cell is revealed. So when is opened true, it shows the cell's value. And the last optional property is highlight. We use it to conditionally add CSS classes to each cell. We set it to red when the game is over when we clicked on a mine, or we set it to green on all mines when we win. The game controls is pretty basic. We can only interact with the closed mines, and so with the left click, if you click on the closed mine cell, it will be a game over. If you click on the closed number cell, we reveal just this cell. If you click on a closed empty cell, we reveal this and all adjacent empty cells together. And with the right click, we also can interact only with the closed cells. And we do toggle flag on the right clicked cell. And also, we cannot reveal a flagged cell. So with the algorithm complete, let's go to VS Code and start building our Minesweeper game. So I'm already in the project folder. Let's type npm create vite following with the dot to set up a Vite React project in this folder. I will choose React, TypeScript, now npm install, and run the local dev server. And it is running. Now let's go back to VS Code and clear the boilerplate code like in app.tsx, clean everything here and here as well. Also go to app CSS and below the root selector, clean everything here. Also let's go to index CSS, clean these styles, also these color styles, h1 tag, and everything to the bottom we should delete as well. After making these changes, you should now see a blank white screen. Also, I've prepared the assets for the Minesweeper game, such as icons and sound effects that you need to download through the link in the description and import it in your public folder inside the project. So let's download it here. Go to VS Code and I will just drag and drop it from the second screen to public folder. So we have 3 icons. The first is a bomb icon, a red flag, and a timer icon. And a few sound effects. Now let's go to app.tsx and add a game surface. It will be a div element with class name set to game. Now let's add styles. Now go to index CSS and add a surface CSS variable and set to this color. Now save this file and go to app.css, define a game selector, set a padding to 0.5 rem and 1.5 rem, background color to our new variable surface, and border radius to 1 rem. Save and let's see what we've got. So in the center we have a small gray game surface ready for more elements. But we do actually need a black surface and also set a text color. So let's go to VS Code and to index CSS file and add app background color and set it to this color, and also text and set it to this color. And here below we need to set background color to the new variable app.bg and text color also set to variable text. Now we see a dark gray background color and we can start adding a game board. As we already discussed, it will be an array of arrays. In order to demonstrate how it will look, let's go to app.css and here I will create an array of some numbers inside, 1, 2, 3, and M ladder. Let's copy it once more and once more. No, sorry, it would be an array of arrays like this, that we need to map through each row, and for each row we render a div element, and inside we map through the row elements by taking each cell and render its value. And this will render 3 rows with 5 cells in each. Now let's go to VS Code and separate the game board into a separate component. So let's click New File, Components folder, board.tsx. Create a new board component. Let's cut it from there and paste it here in the div element with board class. And let's import our new board component here. Click Save and we should still see our draft board. Now we'll style our cells a bit. Let's go to index.css, add a new color variable, call it cell border color, and set it to this color. Now go to app.css and add some styles for the row div and cell div. For the row div, we'll just have display flags, and for the cell, we'll first define its size with the variable cell size, 2 rems, display flags, justify content center, align item center, and here we will define font size, and we will calculate it from the cell size, multiply it by 0.75. Font weight to bold, and width and height we also get from the cell size. We will also define a border. It will be a solid 1 pixel border with the color from our new variable, which is a cell border color. Let's also make sure we cannot select the cell by defining user select none, a cursor set to default, position relative, and box sizing border box. Let's actually close the console and go to the game board. Nothing is changed yet. Let's go to the board component and wrap the cell value into its div with the class of cell. Let's check again, and we're almost there, but we've missed to add class row to each row div. You should now see bordered grid made from the two-dimensional array with values in each cell. But instead of numbers or string, as we already discussed in the algorithms section, each cell will be an object with the value property set to any of the possible values, like a number of adjacent cells or a mine. So let's modify it a bit. Let's make a second cell value 1. For the third, it would be a value 2. And here, let's make it value and actually a mine. Let's copy it from there to the second row. Let's for now set it to 3, 4, 5, and 6. Let's copy it once more and set it 7, 8. Here set to mine, and here set to mine as well. And let's remove the last row. And here we need to use cell value. It should show this board. Kinda looks weird for now, but we'll fix it in a moment. Let's continue adding styles for our cells. We'll add colors for numbers. So each cell will color the number with the individual color. And for that, let's create a constant folder, index.ts file, and let's create a color mapper by typing export const cell numbers colors. It will be an array with these values: null, 1, 2, 3, 4, 5, 6, 7, and obviously 8. Hit save. And we'll use these strings to conditionally color our cells with the CSS classes. Now let's go to index CSS and define new color variables. For the number 1, it will be a blue color. For the number 2, it will be a green color. For the number 3, we'll use tomato. For the 4, we'll use dark violet. For the number 5, we'll use dark red color. Number 6, steel blue. For the number 7, and actually number 8, let's just use the black color. Now go to app CSS and let's define these colors for the individual classes, such as if we set a cell class and also a one class, we set a color to variable 1. And let's copy it many times and we'll modify it to use the appropriate classes and variables. So for the number 2, we will use a 2 class with the variable for this color, and etc. Now to have a conditional logic for each cell, let's go to board component and actually create a separate component for the cell by clicking here a new file, cell tsx, define a component cell and return a div with class cell holding a cell's value with the lowercase cell. And to display a number with the defined color mapper, we will need to add the class conditionally here. And for this, we will use the classic library. Let's install it from the console, npm install clsx. Now we can delete and close it and import it here, clsx. And here in the component, we call the clsx function, and we first check if the type of cell value is number. Then we access our cell numbers mapper with the cell value. Also, our component should receive a cell prop. Now let's import our cell component and use it here in our board. So instead of this div, we import cell component and pass cell object. And now you should see colored numbers on the board, so it works as expected. It's looking funny and interesting, but as you see, we're still showing 0 if no mines are around. But it should be an empty cell, so let's fix that. Let's go to this cell component, and here inside the div, let's make sure that we render a value only if the cell is a number. So type of cell value, number, and then we do render the cell value, or we render an empty string. So hit save and let's see. Yes, now we've rendered only the numbers excluding the 0. And the mines are also hidden. So let's render a mine. Let's go to cell component and first import the mine icon from the public folder /icons/bomb. And here, so let's check if cell value is mine, then render the image tag with source attribute set to mine icon. Hit save, and now you should see a bump icon where the cell value is mine. But let's make it smaller. Go to app CSS and access the cell's image element and set a width to 75%, and for the height as well 75%. Now it looks good enough. But as you know, at the very beginning of the game, all the cells are closed. So let's go to the board component and add isOpened flag and set it to false. So nothing is really changed here yet. So let's go to cell component, and below that, let's check if cell is not opened. Then we do render a div with class overlay. Hit save, and it should render a div. Yes, it renders a div. Let's actually add styles for the overlay element. Go to app CSS, define the overlay class, set it to width to 100%, height also to 100%. For now, let's go to index CSS and also define new colors, which is overlay light. It will be a white color. Overlay mid light gray color, and overlay dark to a darker one color. Now let's go back to app CSS and define a background color and set it to overlay mid color. Let's define border style to solid. Border width to 2.25 pixels. And we'll define 4 border colors for the overlay. So let's type border top color to variable overlay light. The same for the top left. Sorry, for the left color. And we'll have 2 more set to overlay dark for the right and bottom border. And let's also use box sizing to border box, display flex, justify content center, align items center, and also position to absolute, and box shadow 3 pixels, 8 pixels, and kind of dark black color in the RGBA format with some transparency here. Save, and let's see. Now all the cells are hidden with the overlay, showing these nice looking borders and with some box shadow as well. Great. Now we'll render a flag. Let's go to board component and let's try to render a flag with the isFlagged property and set it to true. Now hit save and go to cell component. Let's first import the flag icon from /icons/flag, not red flag .png, and here inside the overlay we do render the image tag and pass a flag icon to the source attribute, and we will toggle the flag's visibility with the CSS. So let's define class name, CLS6 function, and here we'll have a flag class which we will define a bit later, and conditionally check if the cell is flagged. Then we set visible class. And now actually all the cells are flagged because we've not added the CSS yet. So let's go to the app CSS, define a flag class. By default, set it to display none, and if flag is visible, .flag.visible, set it to display block. And let's see, now the only cell that has isFlagged property set to true displays a flag. What if one of the cells is opened and flagged as well? But what if one of the flagged cell is opened? Let's go to board component, and for the opened cell, we also set isFlagged to true. It actually renders properly, and we have no errors in VS Code yet. To avoid bugs in the future, let's add type safety to make sure that we can't just set these properties with these values both at the same time. So let's define types for our board and cell components in the separate file. So let's create a new types directory, index.txt file. And as we already discussed, the cell could vary depending on its property: open it or close it, mine cell, cell with the total mines around. And according to that, we will have 4 different combinations of cell types. Opened cell, it will also be a closed cell, mine cell, and number cell. And actually we'll have a 5th kind of temporarily system property called empty cell that we will use only during the initializing of the game. But the main types are these 4 types. And opened cell will have isOpened property, set it to true, and isFlagged property set it to false because we can't flag the opened cell, so it's by default set it to false. For the closed cell, it will have isOpened property set to false and isFlagged property to boolean, any boolean value. The mine cell will have a value of mine, and it will also have a highlight property, which is an optional. As we've already discussed, it will be red if we clicked on that mine and the game is over, or green when we win the game, and we'll set it to green to color all the mines. And the number cell will have value of any number. And also the empty cell will have value null, which is a temporary value. And the default isFlagged values to false and isOpened value to false as well. And taking the combination of these 4 types, our cells could be opened mine cell, closed mine cell, opened number cell, and closed number cell. And here with the TypeScript, we'll use a type union for opened cell and mine cell. For the closed, it will be a union of closed cell and mine cell. For the opened number cell, it will be opened cell and number cell. And for the last, opened cell, closed cell and numbered cell. And taking these combinations, let's define the main game cell type, which could be any of these 4 values, including this empty temporarily type. Let's also export some of these values like game cell and also these opened types as well, because we will need them in our board or cell components. And for the last, let's also export and define type for the board, starting with board. It will be a two-dimensional array of the game cells, like this. Let's go to board component, and for now let's move the board into the separate board variable. And let's define its type to our new type, tBoard. And now as you see, we have many errors, but the main one is that types of property is flagged, is incompatible because this type is not assignable to the game cell because of this is flagged property. Set it to true. But if you set it to false, we don't have any errors on this cell because we handle the data in our board properly. You still see these errors because we've missing some of the properties like isOpenIt. For now we can just keep that. But this type safety will benefit us in our further development. But the overall logic of initializing the game board will be more complex than that. We'll need a function that generates a grid with desired rows and columns count, as well as with certain mines count. Moreover, it should be able to analyze adjacent cells and calculate how many mines around each cell and display its number. So let's go step by step and create a function that will generate our board. So in CRC folder, let's create a utils folder and index.ts file. Inside this file, let's create two functions and export them. Export const init board and export const init game. Both functions will receive rows, which is a number, columns, which is also a number, and total mines count, which is also a number. And inside init game, we'll call init board function and pass rows, columns, and total mines number, and return the result. Inside the init board, as a first step, will be to create board and pass rows and columns amount, and it will return an empty board. So let's assign a result, a return value from this function, and let's also define it above. Const create board, it receives rows number and columns number. Let's initialize our board with an empty array board, and the board will be in type of tBoard, which we defined earlier. Next, inside for loop, we'll go through 0 to rows amount and create array for each row. Let row index, starting from 0, row index less than rows, and increment the row index, board row index. Inside the board array, it will create rows amount of empty arrays, and it will serve as row in our board. And let's also fill each row array with cell objects using nested for loop. Let cell index less than calls number, cell index plus plus, and now we're accessing the current row with the row index and the current cell in the current row with the cell index equals to value, which is a temporarily null. Later it will be a number from 0 to 8 or a mine string, and we will define it later. Is flagged prop, set it to false, and is opened also to false because we want a closed cell. And finally, below the loop, we return our board. Let's return the empty board for now and try to call this init game function inside our board component. So let's call init game with 3 by 3 and 1 mine. And let's take a look at our board. And yes, we have 3 by 3 board. And if we set 5 by 5, we'll have 5 by 5 board or 9 by 9. For the easy level, we have 9 rows with 9 cells in each row. So let's continue building our init game function. And now we need to fill our board with mines. So let's call our new variable fill board with mines, and it will equal to the return value from our new function fill board with mines. And in this function we will pass our empty board with rows count, columns count, and total mines count. And let's define our new function here, fill board with mines, that accepts empty board. With type tboard, rows number, columns number, and total mines number. In this function, we'll use while loop to fill our board with mines, and we'll track how many mines we already set with the mines counter. And as I said, with the while loop, we track if mines is less than the total mines that is required with the current level difficulty. We do randomly select the row and the column for the cell with the const row math random value from 0 to 1 multiplied by rows, and then round it with the math floor. And also we randomly select the column by calling math random and columns amount. And then we're accessing our empty board with the randomly selected row and column and assign a value to mine. And also we increment the mines count to keep track of how many mines we're already set. But there could be a case that the randomly selected cell is already with the mine value. So we need to check first if the randomly selected cell is not a mine cell. So we type if empty board row column value is not a mine. Then we move this logic here and set it as a mine. And as you see, the TypeScript warning but that type string is not assignable to type number. And this is because we're checking here if it's not a mine, then it could be a number or null, but we obviously need to set it to mine string, so let's modify it a bit so the TypeScript could understand our logic, and let's define this cell object as game cell. And no errors as you see. And when we set the desired mines count, let's return the empty board and also return the board with mines here. And let's go to our game, refresh the page. And for now, to see the contents of each cell, let's also make our overlay transparent here. And this is just for the development purposes, to see the actual contents while we developing our app by setting opacity to 0.5, and now we'll see the contents for each cell, and it will simplify the development process until we finish all the steps to build our game. Now we're just setting only one mine, but if we go to the board component and type that you need 10 total mines, you'll see overall 10 mines in the board. And if we refresh the page, each time you will get a different board with the random places for mines. And the last step is to fill cells with the number of mines around each cell. So let's go back to VS Code, to the utils folder, and the last function that we will create is a board with mines, board with numbers. It will equal to filled board with numbers function. And here we'll pass board with mines board. And that's it, actually. Let's define the last function here. Const fill board with numbers. It will receive board. Simply call it like that with type tBoard. And here we'll go with the board for each loop and taking the current row and the current row index, and also the nested for each loop for each row with the for each loop as well, the current cell and its index, cell index. And then we'll analyze each non-mine cell and we will try to count the total mines around each cell. So first we check if the cell's value is not mine. And we also use here mines around count, starting from 0. And now we need to access all the 8 possible directions, taking the current row index and cell index. When I say 8 possible directions, so let's take this cell. Its row index is 1 and cell index is 1. And all 8 possible directions will be 0, 0, 0, 1, 0, 2, 1, 0, 1, 2, 2, 0, 2, 1, and 2, 2. And for this, we will take current row and current cell indexes and concatenate it with the new directions array that we will define. So let's go to constants file and define and export the directions array that we will use to concatenate its values to the current rows and cells. So it will look like -1 and -1 that corresponds to the top level cell, -1, 0 that will match the top centered cell, -1, 1 that is top right cell, 0, -1 which is a center left cell, 0, 1 which is a center right cell, and the bottom 3 cells, 1, 0, 1, 1, and 1, 2. And using this directions array, which have 8 elements inside for each direction, we first destructure the difference for the row and difference for the column, and then defining the new row, which is a row index plus d row, and also for the column, d column, column index. It should be a column index and a new column, and here like that. And now we check if in this new row and new column position contains a mine by checking if board new row new column value is mine. Then we increment the mines around counter and it will show 1 instead of 0. So in 8 possible directions, it could be up to 8 total mines. But if we take the first cell and the new row and new column index will be -1, -1, so there's no cell, as you see. Let's handle this case as well. And we will handle it by checking if the index is present in the array, by checking if new row index in board, So basically, if -1 in board, which is not, then we won't do anything. But if this index is in board, like 0 up to the rows count, that will check if this cell is a mine. And also, we check if new column index also is an index of the board array. Then we move this logic inside this if statement. And we need to actually increment the mines around counter. The last step to assign the mines around number to cell value to actually display its number. It's safe, and here let's return the board with numbers. Let's actually call it the game board because it's a final game board. So let's save it and go to our game, refresh the page. So we see some errors here. Let's make sure that we return the board in our last function. And yes, it works. Actually, I see that the total counting of mines around is not correct, because in this cell it should be 5 mines, because we see 5 mines here. And for example, for this cell should be 3. So let's go to VS Code and maybe the directions array, let's see. Oh, actually -1, 0 and 1 should be there. Let's see, and yep, total 3 mines adjacent to this cell, 3 for this cell as well, 2 for both of these. Yes, and if you refresh the page with the new board, we see new mines position as well as counting for each cell for how many mines are around. So we filled our board with two-dimensional array with mines and numbers, and let's go back to VS Code and we'll actually move the logic for initializing the game into a separate hook. So let's create a hooks folder and we'll call it use Minesweeper game. Define a hook, use Minesweeper game. And it will have the main state, which is a game board. And its initial value will equal to the result of calling the init game function. And for now, we'll pass 9, 9, and 10 mines. And here, let's import the useStateHook and return an object for now with just the game board state. Hit save. Let's go back to app component and import our new hook here. Use Minesweeper game and extract the game board from there and pass the board to our board component and get it there from props. Game board. Extract it from props, and we can remove the hard-coded board and use the game board there. And also let's define the props type that receive a game board for now with type tboard that we've defined earlier. And also we can remove this init game function import. Hit save and let's see. Yes, it works. Good. We've just separated the logic of initializing the game board into a separate hook. Now, to actually play the game, we'll add interactivity. Let's define the function to handle the cell left click by initializing this function here, handle cell left click. And as a function, a click handler, it will receive the clicked cell row, which is a number, and clicked cell column, which is also a number. Let's just console log a message left click, row and column. Export this function here. grab it in the app component, handle cell left click, paste it to board component, and in board component, we also access it here, and pass it down to the cell component. And in the cell component, we get this from props and pass down to the div for this cell. With the onClick event, we do call an arrow function and pass down the indexes that we'll need to pass through props, which is a row index and cell index. And let's make sure we're receiving them from props with the row index variable and columns, actually cell index. And in board component, we also need to pass these indexes, but we need to access them first there, as well as cell index, and pass both of these indexes, row index and cell index. And finally, let's define a type of this function here. Handle cell left click, a function that receives a row's number, columns number, and returns nothing. We do not return anything. And this type we can move to the cell component, define the cell props above, cell, it is a game cell, row index as number, cell index as number, and that's it. Let's go to our game and click the first cell, and we see its indexes 0, 0. We click this cell 1, 1, the last cell 8, 8, and etc. So we receive the clicked row and cell indexes correctly. So let's continue building the left click logic. And here we'll perform some mutating logic actually. We'll mutate our game board state. But first let's make a deep clone of the game board by defining a new variable, new game board. And using the JSON stringify and JSON parse functions, we'll do deep clone of the game board. So let's type JSON parse and JSON stringify of the game board. And now we see the type any. Let's define the exact type. So it would be a tBoard. And here we'll define a new variable board after opening cell. Because with the left click we open cell, and for this action we'll define a new function, open cell. So let's define this function above, open cell. And this function will receive board with the already defined type tBoard, rows, row number that we'll receive in this function, column number. And after performing the logic inside this function that we'll define next, we'll return the modified board. Let's pass the new game board, row and column number here. After performing the necessary changes, we do set game board state with our new board. But also in this open cell function, there will be cases when we do not modify the board, we won't return anything. So let's make sure that the open cell function returns the actual game board by checking if board after opening cell. Then we do set the new board. Let's go to defining the logic inside the open cell function. And here we'll also do a deep clone with the new game board. Actually the same logic, so we can copy and paste it here. Let's define a variable cell that is a new game board with the clicked row index and column index. And we can console log this object, and let's see, when we click the cell, we return the actual cell's object. And you see its value 1, it's not flagged yet and it's not opened yet. For this cell we see a value mine, and here a value 0 that we just don't display. Value 2 and value 3 as well. And next we'll check what is the type of this cell that you click. It's a mine cell, a cell with a number, or just an empty cell with the value of 0. So let's define 3 new variables. Is mine cell, which is a boolean that checks if cell value is mine. Is number cell. We check it with type of cell value number and cell value greater than 0, and is empty cell with type of cell value number and cell value equals to 0. Now with if statement we check if is mine cell. Let's just console log mine cell. If it's not a mine cell, we check if it's a number cell. We console log number cell, or is empty cell. We console log empty cell. Let's see if we've logged in the actual cell type correctly. So this is an empty cell as well, mine cell, and number cell. Good. In the end, let's return the new game board, and we'll build the logic here. So if cell is not a mine, we set is open as a boolean to true. For this type of cells, which is a non-mine cell, we set the is open flag to true to actually reveal its content when we left click it. And for the empty cell, we need to open this cell and all the adjacent cells recursively. So if cell is empty, we'll use a new utility function called reveal empty cells, and we'll define it in our utils folder. But for now, let's pass the new game board here, current amount of rows and columns on the board. We now have 9 by 9 board, and the clicked cells row and column indexes. Go to the utils file and define this function below, export const reveal empty cells, and as we've already defined it, it will receive a board with type tboard, rows on this level, number, columns on this level, which is also a number, and 2 more numbers, a clicked row number and clicked column number. So when you click on a cell with the value 0, indicating that no mines nearby, it automatically reveals all connected empty cells and stop at the edge where numbered cells or flags appear. So we start with the queue containing the cell the player clicked on. So let's define queue, which is an array of number, and we do the structure assignment here with the clicked cell row and column index, and then the while loop that runs as long as there are cells in queue to process. So we check if queue is greater than 0. So we take the first cell from the queue by defining the current row, current column, and dequeuing it from our queue of cells with the queue shift. Let's take this cell with the board current row and current column and make it opened. Cell is opened true. Oh, sorry, without defining here. Cell is opened true, here queue length actually. So we're checking the queue length of the array, and to bypass the TypeScript warning, because we're sure that we will have any value here. And for the current cell, we check if its value is 0, meaning it's an empty cell with no adjacent mines. Then with the directions array that we've defined earlier, we do check the 8 possible directions here. It kinda similar logic here. So we again define a current row plus difference row, and the same here, difference column, new column. And the condition if new row is greater or equal to 0, or you can use the logic with the in keyword, so you can check as we previously did. But I will show this approach as well for you. New row less than rows amount, and new column index greater or equal to 0, and new column index is less than columns amount. And we also check if the adjacent cell is not opened by accessing board new row, new column is opened. And to actually not open the flagged cell, we also check if board new row, new column is flagged with the exclamation mark, so it's a false value we expect. And if all the condition is met, we do push this cell into our queue like this, new row and new column. And finally, when the queue is finished, we return the modified board. Let's see if it works now, and let's click on the empty cell. Real empty cell is not defined, we've not actually imported there. Reveal empty cells, save, and try again. Ooh. Something is incorrect in our function. Let's go back and see where we've made it wrong. And finally I found that here we should use current column index. And let's go to our game and try once more. And if we click there, so now you see that all the adjacent empty cells are revealed until it's met a number cell. So any reveal logic finishes on the number cell. And let's try once more. So let's click there. And as you see, all the adjacent cells are revealed until the number cell. And click here as well. But if you click on the number, it reveals only the number and only the numbers. But what if we click on mine? So if I click on mine, nothing happens right now. We just console log mine cell that we click on the mine cell. Let's handle this case to notify the player when the game is over. Let's go to use Minesweeper game and create a new state for game over. We'll call this is game over. It will be a boolean value, false by default, and we'll flip it inside open cell function there. If is mine cell, then we'll set is game over to true. So if I save it and refresh the page, let's open up the React Div tools and check its state from the Minesweeper hook. Now as you see, is game over state equals to false, and when I click on the mine, it should set the state for the is game over to true. So yep, it works, and if I refresh the page, so yeah, it's false by default. Also, we would like to highlight all the mines with the red color. And first we will do this with the highlight property on each cell. So we'll use this cell, which is a clicked cell, and set highlight to red color. Now it's just a red string. We'll hit save, and also we'll need to reveal all the mines on the board. So we need to call the reveal all mines function here and pass down the new game board. But we've not created this function yet, so let's save this file and go to our utils file and create this function here below. Export const reveal reveal all mines. It receives the board, and also the second property, which is a highlight win. It is a boolean property that I will explain in a moment. So here we need to use nested cycles to go through each row and each cell in each row. So let's use for each loop and go through each row and go through each cell. And we check, obviously we check if the cell is mine. If the cell contains mine, then we need to open it with the isOpener flag and set it to true. And then if the user is win, we'll pass this second param as true. So we check if highlight win, then we set cell highlight to green. So actually the reveal function goes through each cell on the board and opens any cell containing a mine by setting isOpened to true. And if the game was won, it also highlights each mine with the green color. We'll set the CSS for that in the next step. So let's go to index CSS first and add two more colors here. The first one is red. It will be a fire brick. And the second one is green. It will be a forest green color. Now let's go to app CSS file and define two more classes. Red class to be a background color of variable red, and the same for the green class with the green color. Now in the cell component here in the classes, we can now conditionally check if the cell value is mine, then we render the second part of this statement, which is a highlight, which could be a red or green, or if it's undefined, we don't set any class here. But in case if the cell is mine and highlight property is truthy, meaning it is red or green, then it will set this string red or green as a class for this cell div element. And finally, let's import this function here. Hit save and let's try to click on the mine. So yeah, as you see, all the mines are revealed and the clicked mine cell is highlighted with the red color. And you can also see the red class here with the red color that we've defined. And the same for the winning state. We need to define another state for the game win. So let's define is game win state. It's false by default. And we'll check for the game win inside open cell function. So with the every left click on the cell, we need to check if the user is win. And we will do this inside is not a mine cell if statement. So we can't win if we click on the mine, obviously. So we'll define another rule here. Here we will use another util function called check game win and pass down our board, which is a new game board, and total mines count as a second parameter. Now it's hard-coded 10 mines. If that statement will be truthy, we'll set is game win true. Inside the utils file, let's define this function, export const, check game win. It receives board, total mines, and this function should verify if the player has won by meeting one of the two conditions. All non-mine cells are opened, or all mines are correctly flagged. So in case if you successfully placed the flags on every cell here, the game should be win. So let's define two variables here. Unopened cells with 0 as the default value and correctly flagged mines, starting from 0 as well. And again, with the nested for each loops, row for each cell, we check if cell is not opened, we increment unopened cells, and if cell is flagged and cell value is mine, so if the mine cell is flagged, we increment correctly flagged mines. And below these nested loops, we do the winning condition, which is unopened cells equals to total mines on the board, or correctly flagged mines equals to total mines. So if any of these two statements truthy, the game will be set to win. Basically, the user will win. And also going back to our use Minesweeper game state hook, import this function here. And at the end of the game, we also reveal all mines and pass our board. And the second optional parameter we set to true, to, as you remember, highlight all the mines with the green color. So yeah, let's go back to our game. And let's try to open all non-mine cells. But actually, let's open up the React DevTools to see the isGameWin state. Now it's set to false. Let's open up all these non-mine cells, and now it should be set to true, but yes, we forgot to actually open the last non-mine cell. And yeah, as you see, isGameWin state is set to true and all the mines have green color. We can analyze it and see it in the Elements tab. So all the mines have green color, green class, and filled with the green color. So yep, it works. Now maybe the last thing about a left click. We need to prevent the left click action if one of the following statement is truthy. So if the game is ended, or the cell is opened, or the cell is flagged, we should prevent the left click action. And we can do this inside handle cell left click function by checking in there before we define a new game board with a deep clone with the if statement. So we check if is game ended, or the clicked cell is opened. We access it through game board row column is opened, or game board row column is flagged. Then return null. And we skip all this logic. And let's define this variable here below these two states. Const is game ended. So the game is ended when is game over or is game win. Now let's switch a bit from the cell clicking functionality and take a look at our board. We've hard-coded a board. It is a 9x9 board with only 10 mines on the board. But we would like to have 3 levels of difficulty, so let's define them and go to constants file. And here we'll define and export levels object. It will have three keys, easy, medium, and expert. So each key corresponds to the level name. And inside each object, we'll define the total mines, number of rows, and number of columns. So for the easy level, we'll have rows, we'll have 9 rows, 9 columns, and 10 total mines, as we're having now. But for the medium level, we'll have 16 by 16 board with 40 mines. And for the export mode, we'll have 30 by 16 board with total of 99 mines. And also let's export and define there a default level. It'll be a constant with type T level and will equal to easy, which is this level. And inside the types, let's define this type, which is called T level, and it will equal to key of type of levels, which is our new object for levels system. So the T level type will match all the keys inside this object. Finally, let's import it here, hit save. Let's import the level object inside our hook and define another state here at the top of the hook called level. By default, it will be an easy level. We can use the default level constant here, default level. And above, let's define current level, and it will match the object of the current level with the levels level. From there, we can access the rows amount, the columns amount, and the total mines on the current level, and pass them down here inside our game board initialization. So let's remove it from there and from there as well. And with our current level, we access current level default level. Here we set rows, columns, and total mines. Oh, actually, we need to use levels object. And just before we move to the layout, let's define a function to actually change the level. Change level, and we'll memorize it with the use callback. Let's actually make sure we've imported here. Yes, we've imported. And here will be a function that accepts the selected level with type of T level. And here we do set state with the selected level. And here just an empty array, just to make sure that we won't reinitialize this function every time on every re-render. And import this type as well. Yes. Also, let's replace all the hard-coded values for the current level in our code. And it's about revealing empty cells inside the open cell function here. Instead of 9 rows and 9 mines, we now access it with the current level rows and columns. And also when we check for the game win here, we pass the current level total mines. And finally, let's export the level state and the change level function. Now, in order to be able to change the level, we'll define another component and place it down below the cells, and it will be 3 buttons that will change the level. So let's go to app.tsx component, and here we'll define the select level component. So let's create it in the components folder called select level. It will have level prop and change level function. Let's define these props under the select level props type. The level is just a string, and change level is a function that receives a selected level name, which is a t-level, and it returns void. Now inside the return, we'll define an ordered list with class select level, and here inside we'll map through the keys of our level subject with the object keys method and pass down our level subject. And by using map, we map through every level name here, easy, medium, and expert, and render the list element with key of level name. And here we'll have a button with the level name. And on button, we'll attach an onClick event and execute a change level function. And inside this function, we'll pass the selected level name as t-level. And the last one, to style this button a bit, we'll attach a class name and we'll use clsx function to attach a class if the button is active. So we check if level equals to level name, we attach active class. Now inside app component, let's destructure the level and change level function, and first import the select level component and pass down the level and change level function. Let's see how it looks like. So yes, now it should actually work. Let's check. So refresh the page. No, it doesn't work yet. Let's check what we have inside our state. Easy, medium, expert. So yeah, we've changed the level state, but actually we've not reinitialized the game. So inside use Minesweeper game, let's define here three functions. The first one is reset board, and using the use callback function, we define here an arrow function that resets the game over state to false. It also resets the isGameWin state to false, and reinitializes the game board with the set game board. And here we call init game function with the current level rows, current level columns, and current level total mines. And inside the dependencies array, we set current level. And actually, the last function for now, start new game, also with the memoization, and we call the reset board function. And for the dependencies array, we set reset board function. And finally, with the use effect hook, we listen for the level changes and execute start new game function. Let's make sure we've imported use effect hook, and this effect will run on every level change, because when we change the level, we need to reinitialize the game. And now, if I select the medium, it should render a different board with the different rows, columns, and total mines count. And for the expert, now it's not rendered correctly. it should render 30 rows instead. Let's fix it. Inside the constants, we need actually 16 rows and 30 columns. And yeah, let's check. Yes, we need this whiteboard. And finally, let's add CSS to style these buttons to not look it like it's from 19s. Inside the index CSS, let's add 2 more colors for the buttons. For the button color, it will be this color. And for the active button, we'll have this color. Misspelled the color word here. And inside the app CSS file, let's define a select level class with the display flags and remove the list style type. Remove the padding left. Set a gap to a half on the rem. Set a margin top to 1 rem and the margin bottom to 0. For each list element inside the select level, we'll have flex grow. Set it to 1. And let's style every button here by setting the width to 100%. Display flex. For the vertical paddings, we set it to 0.25 rems, and for the horizontal to 1 rem. Justify content center. Let's add a border radius. And make a small transition for the background color. The 0.15 seconds. And text transform and set it to the capitalized text. And if the button is active, select level button with the active class, we'll have a different background color, button active. And for the button itself, we'll have a button color, a text color for the button, for the surface color. Let's remove the border, set a padding, make a font size a bit smaller, have a border radius, and a bold font. And yeah. And now we see these solid buttons for every level, and the active button will have this gray color. So if I select different level, the button will have its active status. As you see, the board becomes huge when we change the level. We can handle this with CSS and make the cell size a bit smaller for the medium and expert levels. So inside the app component, let's pass down the level to the board component. Inside the board component, let's access it from props and define it here in types. And next, pass down the level to the cell. Open up the cell component, access the level here, define a level prop here, and inside the classes for each cell, we conditionally check if the level is not easy. Then we apply another class called small. And in app CSS, let's scroll down a bit to the cell class and define here a class .cell.small. We redefine a cell size variable to make it a bit smaller. So this will rewrite the variable that we have here. So every cell with the class small will have a smaller cell size. And let's check if it works. So as you see, on the expert level, the board became smaller. On medium as well, it is smaller, and on easy, it is a bigger one. And now it is not jumping too much when we change the level, so it kind of stays on the same size for every level. Now, for the right click, we have to consider the following. We need to toggle the flag with the isFlagged boolean and display the flag icon. We also need to check if all mines are flagged correctly, and if so, trigger a game win. And also make sure we don't place a flag on the opened cell, as well as to track the total flags with the state. So inside our hook, let's define another state called total flags. By default with the 0 value. And here below the handle cell left click, let's define a similar function. Handle cell right click, and it will receive an event, which is a mouse event of the HTML div element, row of the clicked cell, and column. And for the right click, we have a default behavior for every browser that we open the context menu. So let's bypass this action by preventing the default behavior with event.preventDefault. And let's import the mouse event from the React library. And here below, first we check if is game ended or the cell is opened. We just return to prevent any action if any of these statements are truthy. And now we call setGameBoard function, and with the callback function we access the previous game board, make a deep clone for the new board here, and define a cell variable that is equal to the clicked cell. And here, first we check if cell is flagged. We flip the isFlagged property and set it to false. So new game board, row, column, isFlagged, set it to false. And let's copy it and paste it here, and if cell is not flagged, then we set this flag to true. And also let's return our new game board. And also we'll track the flags difference with the flags difference variable here. And if we've removed the flag, we check if flags difference is 0 and decrement it. The same for the setting the flag, we increment it here. Below the setGameBoard function, we set total flags with the callback function, previous total flags, and concatenate the previous total flags value with the flags difference. So if we've set a flag, then we'll increment it, previous total flags plus 1. And if we've removed the flag, we'll do previous total flags minus 1. Finally, let's save the file and export this new function here. Go to the app component, destructure it from there, and pass down to the board component. Go to board component, define it there, and you can actually check its type here. Just copy it from there and pass down it here. Handle cell right click and pass down to every cell component. And again, copy the type of this function and define it here inside the cell props. destructure it from there, and on the actual div of the cell, for the right click, we have on context menu event. And this function receives an event, and here we will execute handle cell right click function and pass down our event to actually prevent its default behavior, row index and cell index. Hit save and let's try to right click the cell. So now as you see, we've set in the flag, and if I again right click, we've removing the flag. And if I open the cell and try to right click, we're not setting the flag to this cell. And for the empty cell, we also can't set the flag, which is a correct behavior. And the last element that we'll add to our game is header, with controls like start a new game or restart the current one, game status showing how many mines are left to find, and timer. So let's go to the app component, and here let's define a header component and create a new one, header.tsx, and let's just return the header element. Import it there, and inside app.css file we'll define its styles with the header selector and set it to display flags, justify content space between, align items center, padding. We set vertical padding to 0.5 rems and 0 for the horizontal padding, font weight bold, and font size 1 rems, and we'll disable the text wrapping with the white space, no wrap. And now the header is appeared there with no elements inside yet. So let's add a first component to our header, and it is called game status. This component will work in this way. It will display mines left count equals to total mines minus flagged cells. Or it will display game over text if the game is over, or it will display game win if all mines are flagged correctly, or all non-mine cells are opened. So let's create this component here, game status. And it will receive props, which is game status props. Let's define it above, type game status props. And we will need 4 values here. Is game win, is game over, is game ended, and mines left. The mine left is a number, and all of these 3 values are Boolean values. Here we will do the structure assignment for these props. Is game win, is game over, is game ended, and mines left. Inside the return statement, we'll use fragment, and first we check if is game win, then we render a span element with text you win. But if the game is over, we render game over. And the last, if the game is not ended, then we open up the brackets and another fragment. And here we'll render the total mines left count along with the bomb icon that we'll just import in a moment. So the image tag with the src equals to, let's import the bomb icon. Let's import it there at the top of the component, bomb icon from icons bomb.svg. and pass down here into the source. And for the class name, we'll have header-icon class. Hit save, and here we'll also receive the props, header props. And all these 4 values, we can just copy and paste it there, as well as this destruction. And select all these values and pass down them. And import game status component. And finally, get is game over state, get is game win state, is game ended, and mines left count here. And also pass to the header component. We can just select this text and copy to the header component. It says the property doesn't exist because we've not exported them. So is game win, is game over, is game ended, and mines left. And finally, let's define a number of mines left. Let's scroll a bit to the top, and here below the total flex state, we define const mines left, and it will equal to current level total mines, which is a total mines count, minus total flex that we've placed on the board. And now you see a giant bomb icon and the mines counter, and if we place a flag, we see the counter is decremented, and if I place another flag, the counter is again decremented, and if I remove the flag, it is incremented and incremented once more. Let's style this block a bit to make an icon smaller and to place it on the left of the header. So inside the app component, we define these classes. Win class, color set to variable cell mine green, game over, game dash over, color to cell mine red, and the sizes for the header icons, header icon width 1 rem and height 1 rem. And also the last style, header label. We'll need it in a moment. Display flex, align item center, and gap to 0.25 rems. So now the game status have better look, but the number is placed on the right, but we'll fix it when we add more elements to the header. So let's leave it just like that and just move to the next element. And it is a timer for our game. Let's open up the header, and here the next component will be called timer display. Created there, timer display. Let's import it there. For the timer logic, we'll create a separate hook that will handle all the functionality for the timer. So inside the use Minesweeper game, we'll add another hook here, like below the mines left count, and we'll call it use timer. Let's define this hook there in the same folder, use timer.tsx, use timer. In React, to run and stop timer, we need a useref hook to store a timer's instance. So let's define a new timer interval instance. And it is equal to useref with default value of null and the type of value for the TypeScript, null or number. And our timer will work in the following way. So when we start the timer, we save a date object with the information when we start the timer. And with the use effect and set interval, we'll track each second the difference between the time now and the time where we started the timer. So we will need a state that's called time started with the default value of null, but when we will start the timer, it will hold the date object. So the type will be a date or null. Let's import the useState hook as well. And another state, time now, to keep track of the current time. Also null as the default value and the type date or null. And to start the timer, we'll have function, simply call it start timer. And it will be a memoized function with the use callback hook and with the empty dependency array. And we've just do set time started new date. To count the timer, we'll use useEffect hook with another callback function here, and we'll assign to timer interval current value a set interval. So this set interval function will be called each second to set the time now with another new date object. And in the dependencies array, we'll have a time started. And also, we don't want to run this effect if the time is not started. So if no time started, we just return. So we've created a start timer function that we can now run on the first click to actually start the timer. And obviously, we would need a function to stop the timer. It is also a memoized function that just clears the interval with the clear interval function and pass down time interval current value. And also, again, with an empty dependencies array. Let's just keep this error from the TypeScript and leave it like this. And also, to reset the timer, we'll define the last function here called reset timer, use callback, and here we'll set null for the time started and time now. Set time started null and set time now null. And again with an empty dependencies array, so we've defined this function only once and use it without reinitializing it. And inside the return statement, we return an object with these three functions: start timer, stop timer, reset timer. And the last values that we'll add is a time difference and a boolean that checks if the timer is running. So the first one will be time difference, and it will be a memoized value with the use mem hook. So here will be a function, an arrow function, that calls a new utils function called get time difference. And inside this function we'll pass time now and time started. And for the dependencies array we'll have time now. And again, inside the utils, let's define this function here, get time difference. The first param is time now, which is a date or null. And time started, also date or null. And here we'll need to return a string with 2 digits for minutes and 2 digits for seconds, separated by a semicolon. But first, we check if time now is null or time started. Actually, I've misspelled it there, time started is also null. Then we return a default value for the timer, 0 minutes and 0 seconds. And if it's not truthy, then we need to format the string to equal to the actual time difference. And for that, we'll use datetime format method. We'll use default locale, United States. And inside the options, we pass a minute key and equals to 2-digit to have that 2 digits for the minutes. And for the seconds, we can use also 2-digit. And then format time now get time minus time started get time. Then import that function inside the useTimer hook and export that time difference string from this hook. And the last value is timer running. It is a boolean that checks if we have a truthy value inside the time started state, and also included in the return statement. So yeah, and let's copy these values, this object actually, and here let's import the useTimer hook and let's define all these values like this, and now we can start using this timer functionality to actually start, stop, and reset the timer. So inside the openCell function, we first check if timer is not running with the isTimer running. Then we do start timer. So in this way, we make sure that we run the timer on the first left click. And the same, we can copy this line here for the right click. Below this return statement, here we can pass this line here to actually run a timer if we start the game with placing a flag. Also, we need to stop the timer when the game is ended, and for this we've already have isGameEnded boolean. So let's define another useEffect hook that will track if isGameEnded. Then we do stop timer if isGameEnded. And inside the dependencies array is GameEnded value and the stop timer function. So yes, like this. And let's define this effect below the useTimer hook there. Now let's scroll down to the bottom, and inside the return object we need a time difference to be able to pass it to our timer display component through app component. So let's access this value here, time difference, pass it down there to the header. It is a string value. Go to timer display component and access this value here, time diff string. And here we'll just have a fragment with the time difference string and the timer icon to the left of the time difference string. So let's use the image element and pass down a timer icon as a source for this image. And also the class that we've already defined, a header icon, and import the timer icon from icons. So here we have our timer icon, icons, timer.svg. So let's see how it looks like. Refresh the page. And now you see that the timer is appeared in the board, but the gap between the icon and the text has somehow broken. So let's see what's the issue behind it. So yeah, I know. For each element inside header, we need to have a wrapper called div header label here and here for the timer display and place the timer display and game status inside this header label elements. Save, and now the game status is placed to the left of the header and the timer is here to the right. And if I start the game with the left click, you see that the timer is started to ticking, and if I click on the mine, the game is over and the timer stops. Refresh the page, and with the right click, by placing a flag, we should also start the timer. Yes, it works. And again, the timer should stop. And the last element for the header, we'll add two icons here at the center of the header to actually start a new game or restart the current one. So here we'll have another div with the header buttons class and with two buttons inside. The one is a new and restart. And for these buttons, we need two functions. Let's go to the use Minesweeper game hook and check if we've already have these functions. So we have a start new game function and reset board function. So yeah, for the new button, we'll use start new game function. And for the reset, we define another function, restart game, memorize it, and call reset board. And also a few adjustments to the reset board function, because we've already added a flex counter, a timer, and we need to reset the timer when we click on any of these new buttons here. So here we'll first do stop timer, then we do reset timer, and reset the total flex count with the set total flex and set it to 0. And then here, depending on if we wanna start the current game with the same mines position, we need to check if we just want to restart the current game. We'll do this with the if statement, is restart, and it will be a boolean that we can receive there inside the reset board function, is restart, an optional boolean value. So here we'll define a logic to restart or to reinitialize the current game board. But if we've not restarted the current board, we'll just generate a new random board like we did it before. So yeah, inside the restart game function, we can just pass true. So for the restart game function, we'll use another logic that we'll just define in a moment. So in order to restart the current game, we again can also use two nested loops to reset all the flags and make all cells closed, and that's all. So let's call setGameBoard, and with the callback function we access previous game board. And then we can actually, with the map methods, we map through each row. And again, map through each cell in every row. And return an object for every cell with the value equals to cell value is flagged to false, and is opened also to false. Export the restart game function because we've not, and start new game function as well. Get it there, start new game, restart game. pass down to the header component. Define in the header props. And use it here with the onClick event. Start new game. And onClick, restart game. So yeah, let's see if it works. Refresh the page, start a game and click new, and the timer stops and resets. And every time I click a new button, we generate another random board. And if I've started already the game, if I click restart, it should stop the timer and just reinitializes the current game board. And finally, let's add a bit of margin between these buttons. Inside the app CSS file, header buttons, display flex, and gap 2.5 rems. Now it looks better. And we've almost finished with the game, but we need a few final touches. On the classic Minesweeper game, the first click is also a successful one, meaning that you can't click on the mine with the first click. And we can handle this case. So when we click on the mine, I will show you once more. So I want to generate a new board if my first move was a click on the mine. So we won't receive a game over for every first click. Instead, I want to generate a new board to actually make a first successful move when I start the game. So inside the handle cell left click function, we can refactor this code a bit and define another variable here, which is a mine cell, that we just track if the clicked cell is a mine. Then we track if it is a first click. And the first click is when the timer is not running. And to actually use a string mine for the value. And finally is first click on mine is when it is a mine cell and it is a first click. And now we can use this value like this. If it's first click on mine, then we want to generate a new board until the clicked cell will be not a mine. So we'll generate a new game board, init board with current level rows, current level columns, and current level mines. While new game board row column value is a mine. And let the new game board value will be in type of tboard here. Import the init board function, or else we just assign a new game board to the game board state that we already have. New game board. I've misspelled it. And probably that's it. It should work. Let's test it. So let me refresh the page, and if I click on the mine, so as you see, the board is regenerated until that cell will contain any value but not a mine. And again, so yeah, the board is regenerated, making a first move a successful one. In the next section, we'll add sound effects. Sound effects provide instant auditory feedback for different game events, such as revealing a cell or flagging a mine. Let's go back to VS Code and we'll create a custom hook called Use as Effects. And here we'll manage and play all the sounds. First, let's import all the necessary hooks that we'll need in a moment, like use callback, use effect, and use state. And below, let's define a sound list. It will be an object, assign it to sounds list variable, and we will map the sound names to their file names. Like for the first effect, it will be a reveal empty cell, reveal empty, and it will equal to reveal underscore empty dot wave, which equals to this audio file. And here, in the same way, we should fill this object with all the sound effects we have here in this folder. Let's continue. Reveal number equals to this file name, reveal underscore number. The next sound effects is flag place dot wave. And we do this to actually prevent any misspelling on the file paths, to have a one place where the file names are placed. The next effect is flag remove dot wave, and two more, game over and game win. And to add more type safety, we'll need two more types, like t sound name. It will be key of type of sounds list that equals to all these keys in this object. You can see it there. And type t sounds list. It will be a record, which is our object. T sound name, HTML audio element. We'll need this type in the hook that we're just about to create. And let's create the hook itself. We'll call it use sound effects. And here we'll load and preload all the audio files to ensure them smooth playback during the gameplay. To preload and save the audio files, we'll use sound list state, and with the use effect hook, we'll load each file in this sound list as an HTML audio element. So let's create a state sounds list. The default value is null, and the type will be t sounds list, or null default value, and the t sounds list is this type that we've defined, and as you see, it will be a type equals to HTML audio element, which is a preloaded audio, as I mentioned it earlier. And inside use effect, we first check if no sounds list. Then we need to preload. First define a list, which is an empty object as t sounds list. Next, with the for in loop, we go through each key in sounds list, const sound in sounds list, and we'll define list sound, which is each of these sound names, equals to new audio object. And here we need to access the public folder. Next, go to SFX folder and concatenate it with the file name. And we can do this with the sound effects / plus sounds list sound. But actually, to avoid bugs when we deploy this to GitHub or any other resource, we should handle the public folder properly and ensure that we respect the base URL setting in vidconfig file, and to prevent any errors when loading assets. That's why we need to use there a base URL that is accessible through import meta env base URL in vid. And next we should preload the audio by accessing our new audio object, list sound, and call the load method. And finally, we need to set our list of all the keys and their values, which is our audio objects, and use a set state function, set sounds list, and to set a list to this state. And we don't need this return. Hit save. And here we actually need to let TypeScript know the type of the key that we're using this for in loop. And we'll define a sound as a separate variable with the let keyword, sound as a tsound name, and remove the const here. And now it should work. Next, to actually be able to play the sound effects, we'll add a function to play a specific sound when triggered. Below the use effect, let's create this function called play sound effect. We'll memorize it with the use callback hook, and here we'll define the function itself. It will receive a variable which is a sound effect name that is in type of tsound name. And here we'll use try-catch loop, and inside it we'll first access the audio object within const audio sounds list, which is our state with the preloaded audio effects, and access them with the optional chaining as effects name. And next, if there's an audio, we first stop any ongoing audio if there's a playback. Then we reset the current playback position, which is a current time, to 0. In other words, we scroll to the very beginning of the audio file and we actually play the sound with the play method. And we can also handle the errors within console warn message, like unable to play sound and display an error. And don't forget the dependencies array to re-render this function, and it will be a sounds list. And finally, we can return and export this function in the return statement. And now we can go back to our main use Minesweeper game hook, and at the very top we can import this use sound effects hook and define it. Let me choose where we should define it. Let's place it there. Use sound effects and extract the play sound effects function. And we can call this function when interacting with cells. Like, let's scroll down to the open cell function, and inside the isMineCell if statement, when the game is over, we can play sound effect, which is called game over. And if it's a 0 cell, we can play the sound effect for the empty cell. Play sound effect, reveal empty. And if it's a number cell, we can play the sound or the reveal number sound. Next, if the game is win, we can play sound effect, call it game win. Scroll a bit down to the handle cell right click function. When we place a flag, we play a flag plays audio file. And if the flag is removed, we play a sound effect, call it flag remove. Hit save and let's go back to our game and let's try to interact with the game and to see how sound effects are played. So when I click on this cell, as you've heard, the sound for the reveal number is played immediately. And if I click once more, the sound for the reveal empty is played. If I place a flag, we've played another sound effect. If I remove a flag, another sound effect is playing. When I will click on this cell, the game will be over and you will hear a boom sound. And the last sound effect is for the game win. Let's try to win this game to actually hear this sound. I found why this sound wasn't played, and this is because we win by placing a flag correctly, and we should handle the play sound effects function here also in this handle cell right click function. So let's add a play sound effect function and call game win effect here as well, not just in the handle cell left click, but when we also right click and win the game. Hit save and let's try once more. I will start a new game and we'll try to win. And now you've heard the game win sound. And the very last step for this tutorial, we'll add a confetti animation. Confetti animation will provide us a celebratory effect when the player wins the game, adding a visual layer of feedback. Let's go back to VS Code and we'll add a React Confetti library with the npm I React Confetti. We can close this and open up the app.tsx component, and here let's import React Confetti library. And here we can check when is game win, then we can render a React Confetti component. Hit save and once more let's win this Minesweeper game. That's it, confetti for the win. How cool is that? We've come a long way to build this Minesweeper game from scratch. Along the way we worked on core algorithms, board and cell logic, styles, type safety, and made it come all to life with interactivity and sound effects. But this is just the start. You can improve your game by adding a high score table, letting players choose custom board sizes, creating themes to make it unique, or even adding a multiplayer mode for extra fun. The possibilities are endless, so get creative and create it your own. Thanks for following along. Keep learning, keep building, and I will see you in the next video.